Hi students, problem number 6. If the coefficient of friction between two blocks of masses 2 kg and 3 kg is mu equal to 0.5. Find the acceleration of each block if the applied force F is equal to 5 Newton in the first case and 20 Newton in the second case. So this is a diagrammatic representation of two masses stacked one over the other. The 2 kg mass is placed over the 3 kg mass, and the system of two blocks is kept over a frictionless surface, that is the smooth surface. But there is a friction between 2 kg mass and 3 kg mass. So now we will calculate what is the maximum frictional force. Okay, so F is maximum. This is the maximum frictional force between the surfaces 2 and 3. So this is equal to mu into M1, that is 2 kg, into G. So this is now equal to 0.5. This is 0.5 into 2 into 10. So this is equal to 10 Newton. So now the applied force 5 Newton is less than the frictional force. Since the applied force is insufficient, the block 2 kg will not slide over the mass of 3 kg. So what is the impact of this force 5 Newton? It is going to accelerate the two masses together. Okay. So the acceleration of that is M1 does not move. Is it not? M1 does not move alone. M1 does not slide alone. Together they are going to move. Therefore, the acceleration of the 2 kg mass is equal to the acceleration of the 3 kg mass, and that is equal to A. So this is the applied force. So this 5 Newton of force must be equal to the total mass 3 plus 2. Okay, 3 plus 2 into acceleration. So this is equal to 5A. Therefore, A is equal to 5 divided by 5, and that is equal to 1 meter per second square. So this is the acceleration of M1 as well as M2 when in the case when F is equal to 5 Newton. Now in the next case I am going to take the applied force is 20 Newton. So this 20 Newton is greater than 10 Newton, is it not? So this is the opposing force, frictional force is 20 Newton. So applied force is greater than the frictional force. Therefore, the mass 2 kg will have a separate acceleration, and the mass 3 kg will have some other value of acceleration. So only the 2 kg mass you take. The direct force is the applied force 20 Newton, and the opposing force is 10 Newton. Is it not? Here it is 10 Newton only. Okay. So the resultant force is going to accelerate the mass of 2 kg with an acceleration A1. So I will write now 20 minus 10. So 20 minus 10 is equal to mass 2 into A1. So this is 2 into A1. So this is 10. 10 is equal to 2A1. Therefore, A1 is equal to 10 by 2 is equal to 5 meter per second square. So A1 is the acceleration of the first mass, and that is found to be equal to 5 meters per second square. Okay. Now there is no direct force acting on the second mass. Here we have to understand carefully. There is no applied force or direct force acting on it. The frictional force acting on the first mass and its reaction is also 10 Newton. This is acting on the second mass because this 10 Newton is acting between the 2 kg and 3 kg masses in the left side. Is it not? This is action force, and the reaction force will be equal in magnitude but opposite in direction. That is the one and only force which is going to accelerate the 3 kg mass. Therefore, this 10 Newton must be equal to 3 kg into acceleration A2. So this is 3 into A2. Therefore, the acceleration of the second mass must be equal to what? 10 by 3 meter per second square. So this is the acceleration of the second mass. So my dear students, in the first case, The applied force is less than the frictional force. Therefore, the 2 kg mass cannot have a separate acceleration. Why? Because it does not move. It cannot move, it cannot slide over the second mass. That is why the two masses together are having the same acceleration. Okay? But in the second case, since the applied force is 20 Newton, which is greater than the frictional force 10 Newton, this will accelerate over this will slide over the second mass with an acceleration A1. Okay? And the reaction force due to the Fs, frictional force, will act as the applied force here. So this 10 Newton must be equal to 3 into A2. Okay? So this is how we have to solve the problem. I hope you must have understood well. Fine.